Okay, so in this video we're just going to use what we already have and look at how to actually make a function well documented and usable by anybody else who wants to use it. After all, the point is that if we're going to be writing code, we should make sure it's bug-free and also, um, you know, well documented so that others know what exactly it does. So first of all, let's consider this problem. Given the two legs, I guess we mean by like given the length of the two legs, right? Of the two legs of a right angle triangle, find the length of the hypotenuse. So basically we're supposed to be applying the Pythagorean theorem. If you didn't already know what it was, well it's just assuming the legs are leg 1 and leg 2, then we could do leg 1 times leg 1 plus leg 2 times leg 2 equals the hypotenuse times the hypotenuse. So basically, leg 1 squared plus leg 2 squared equals the hypotenuse squared. You might have heard it as a squared plus b squared equals c squared. Anyways, so what we need to do is we need to find out the h over here. Okay? You should probably look it up if you don't understand this formula. Anyways, let's look at this sort of process for actually figuring out what the function is and well documenting it. The first thing is the function header. This is going to be basically how anybody would call the function. So if you remember from the previous video, we defined multiply. So that right there is the function header. So if I were to write a function header for this problem, well, I would have to say, well, we're going to have a define statement, and we're going to be calling it, let's say someone wants to call it as find hypotenuse. And then obviously, we're given the length of the two legs, so we would need, let's say, leg 1 and leg 2 as our parameters. That way we can pass in numbers as arguments. And we shouldn't have anything else because that's all we need to find the length of the hypotenuse, because we're already given that it's a right angle triangle. Okay? So we don't really know what to write with this yet, so we're just going to put a dot 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 and do this. In technicality, just to like save your code or whatever, you can probably just put a comment there because you're not actually done with it. So we've written our function header. We can now write our purpose, and you should probably do this double comment right purpose. So we can literally copy down part of the problem here. So we can say produces the length of the hypotenuse given the lengths of the two legs, leg 1 and leg 2. Okay? So our purpose is good because one, we're working in a in a functional language. So instead of returning values, we're actually producing them. So functions don't return values as they do maybe like in C or C++ or Python. They produce the values. And also what we're doing is we're actually using our parameters inside of our purpose statement. So it's easier for someone to figure out what our function actually does. Oh, it uses leg 1 and leg 2. Those are the lengths of the two legs from which we can find the length of the hypotenuse. Okay? Alright, so now that we've done the function header and the purpose, we should do the contract. Now the contract specifies what the two types of data, leg 1 and leg 2, should be, and then what we should return. As in, well, we know that length is it's a numerical value. So what we can do, contract, we can say, well, we're going to take a number and another number, and it should produce a number. Now we can also modify this contract. For instance, we don't really want to be dealing with negative numbers because, at least for our purposes, it doesn't make sense for a triangle to have like negative length. So we can modify the contract by saying, you know, let's say num is greater than 0. Okay? And this should really be everything for this case. There's more difficult contract specifications that we can have later, But for now, we're just going to deal with this one function and hopefully get through everything without too many problems. Okay, so now that we've had our contract, we can have some examples. Because if our client, if someone is to look at this function, they should know, oh, okay, that's a nice example. I know how this works now. So what we would have to do is, in here, we can probably just write a check expect statement. Because what you can do is, if you write this check expect statement, and you call, find hypotenuse on, let's say, 3 and 4, we know that the answer should be 5 because 3 squared is 9, and then 4 squared is 16, 9 plus 16, that's 25, and the square root of 25 is 5. Now we should probably comment this out simply because we don't yet have we don't yet actually have the function, so if we try to run it, it's going to complain because find hypotenuse isn't properly defined since we've commented it out when we were writing the function header. So usually one test is good, but I like to go with 2. It just looks nicer, I guess. You don't have to go with 2, but generally it's a good idea to get varying kinds of data, I guess. So here you can try, I'm not really sure, but I guess we can go with 5 and 12. 5 and 12, I believe, should give us 13. This is just a Pythagorean triplet, I know. So, once we have these two, we've done our examples, and now we actually need to write the function body. So, let's go ahead and uncomment this. Let's just uncomment it, and then we can start writing out what needs to happen. Well, looking at our formula, we know that it should be a squared plus b squared equals c squared. So, well, first I'm going to have to add them together. Well, I guess when you're writing racket functions, you're going to think like in reverse. Like, what's the last thing I need to do? Well, I need to add together a squared and b squared. Okay, well, now what's the second last thing? I need to actually square the values. I need to square the leg 1. I need to square leg 2. And this is my first attempt at writing a function body. Hopefully everything works out fine. But let's just go along with what's next. So the next thing is tests. These are basically more of these, and you can leave them, like you can uncomment these now. But I'm just going to write some check expects. Check expect find hypotenuse. Maybe I should have picked a smaller name for the function name. Anyways, so one Pythagorean triplet I know is 6 and 8 make 10. And it's interesting because 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So you can come up with Pythagorean triplets pretty easily. We can write more tests, but you get the general idea. What you're going to be doing is you're going to be coming up with these on your own. If I really want to, I can do a check within. Since the square root of a number isn't always a nice number. So for instance, if I was going to be doing, let's say, 4 and 5, well, I don't really know what the square root of, what is that, 16 plus 25 is. So let's just find the square root of 16 and 25. And that is 6.4031. So what I can write here is 6.403. And then this check within allows me to find the hypotenuse, compare this answer to this answer. And as long as there are, I can specify here 0.01. As long as there's 0.01 within each other, this test will pass. Okay? Because we know that the hypotenuse may not always be an integer, even though these two are. Okay? And of course, these two don't even have to be integers. We can just leave them to be whatever they want. They can be decimal values or fractions. So we've written our tests. Let's run the program and see what happens. So if I run the program, it says find hypotenuse. The function isn't defined. Oh. Spelled hypotenuse wrong. Okay, so let's run this again. Find hypotenuse. Yeah, I really should have picked a smaller function. So it says it ran 2 tests, 0 test passed, no signature violations. We should probably expand this and see what happened. So check failures. The actual value 100 differs from 10, the expected value, and the actual value 41 is not within 1 over 100 of the expected value of 6.403. So basically, the tests that we wrote here, these two, they didn't pass, but it looks like we forgot to do something, because 10 squared is 100, and 6.403 squared, well, it looks to be near 41, because, 6 squared is 36, and 7 squared is 49, and 6.4 is between those two, and 41 is between 36 and 49. So it looks like we forgot to actually take the square root. So this is the part where we're revising. We're revising our function definition, the function body, and fixing it. So let's put in the square root, and then the ending bracket, so that this part is properly binded to this part. Remember, define is still only taking 2 arguments. Anyways, so now that we've fixed this, let's see if everything works. Both tests passed, and just for being extra careful, we can check these as well, and they should. Okay, find hypotenuse. Okay, so all 4 tests passed. So if you look at the actual process that we went through, we didn't define the actual function until a bit later. But now, if someone says, well, I need something that gives me back the value of the hypotenuse given the 2 lengths of the legs, then they know exactly what to do here, because they can see, well, this is exactly what the function does, and this is what I need to put in for leg 1 and leg 2. Here's the contract. It takes 2 number values, so I shouldn't be giving it like a string or a symbol. That's not going to make sense for the function. And also, well, here are some examples. There's check expect, another check expect. Okay, so if I find the hypotenuse of 3 and 4, it should give me back a 5, and that's how I would use it. Normally, people will know that you don't actually write in check expect. You can just use, like, you're only going to be running find hypotenuse. You're not going to be running check expect find hypotenuse. But these work well for our own purposes of testing, as well as giving examples. So once we've written the examples, we have our function body, write the actual function body, because to be honest, when we were writing our examples, we had to have carried out the calculation by hand. So on your paper, you may have realized, okay, well, what I'm doing is I'm squaring the 3, I'm squaring the 4, and then I'm taking the square root of that to get the 5. And then that's when you coded that into your function. After you do a few examples by hand, you should know what you want a computer to do. Okay? And Racket is really nice in the sense that many things model mathematics very nicely. First do this, then do this. Once these two are both numbers, add them together. Once that is a number, take the square root of that, and that is the value you produce, because that is what this is bound to. Okay? So this was a quick example on writing a basic function using all of the elements of the design recipe or problem-solving style, whatever you want to call it. Okay? I'll see you in the next one.